Good morning, everyone. Welcome to Algebra 2 class. As you know, yesterday we learned solving quadratic equations by factoring. We practiced many problems. And today's lessons, by using those factoring skills, we're going to learn how to graph a quadratic equation given in a standard form. And the leading coefficient is just one, specific one. And then we're going to do one graphing example in a detailed form. Afterwards, I'll put you in a breakout sessions, a group of 3, and I'll check with you. I'll check each room and answer your questions. And before we finalize the day, we're going to have a exit ticket as one more question and complete our lesson today. So, today, our main learning target is, again, we're going to learn how to graph quadratic functions, but specific one, factorable ones. Because not every quadratic function is factorable. So we assume that it's factorable in today's practice. And it has to be in a standard form. And that is the standard form, by the way. X is missing over there. It has to be bx over here. So ax squared plus bx plus c. Let's call them quadratic standard form. Y equals. And again, our specific criteria, a must be 1. So when a is not 1, those coming days, tomorrow and the other day, next day, we're going to learn those as well. So we're going to cover up. And end of the day, for your self-assessment, you'll be able to apply the factoring skills and strategies to graph quadratic functions in standard form. So what it means, for example, they give you a question like this. As you can see on the left side of screen, that quadratic function. And say graph this function, find those important points, and you should be able to do that. So before we get into detailed problems, sorry. Let's take a look at an example graph. By the way, this is the scale graph of this function. So we're going to learn how to graph it today. So there is no way to know every single point on the graph. That's why we need to focus significant points, which means the good idea to know the vertex, turning point, those points coordinate, those x-intercepts, 2 of them. A quadratic function may have no x-intercept, only 1 or 2. In this one, we have 2 x-intercepts. Exact points. So we should know that where graph crosses x-axis. Also y-intercept. That point. So x-intercept, y-intercept, and vertex coordinate. If you know those significant points, you can graph any quadratic function. And also, other point is quadratic function may parabola. By the way, the quadratic graph it's called parabola. The name of the quadratic function's graph is parabola. May open up or opens down. 2 possibilities, and that depends on the leading coefficient a right over here. If a is bigger than 0, positive, your graph opens up. If a is negative, graph opens down. And don't forget that a cannot be 0. Because in a quadratic function, if a is 0, imagine a function like this. 2x squared plus 5x plus 6. If a is 0, that will be 0. And the rest of the function will not be quadratic. That will be linear. So a must be a real number, negative or positive. So then if you know those 3 or 4 parts of information, you can graph a scale graph. So let's make a list of those data we need to be able to graph. So the question we're going to ask ourselves, so what do we need to be able to graph a quadratic function? So you see 2 examples, visual examples. Those are scale graph as well. That's the function, and that is the function. So you see on the left side, left graph, function opens up. You can immediately, conclude that a must be positive over here. And by the same logic, a must be negative from the left side. So before you graph, you know that that's what's going to happen. Also, to be able to graph this, we have two x-intercepts as well. You see, that point should be known, two of those. And that's the vertex point has to be known. Also, y-intercept right over here. So we have to know x-intercept, y-intercept, vertex, and also a is positive or negative. So step by step, we need to get those informations, make those mathematics calculations, and once they are ready, those are essentially a point. For example, x-intercept means an x-coordinate and y is always 0. Y-intercept means an x-coordinate, always 0, and a y-coordinate over here. And vertex has both coordinates, x and y. And sometimes that could be 0 as well. Okay, let's get started our example 1. So today we're going to go over in this example in detail form. This is our function. X squared minus 6x plus 8. That fits our today's definition. So leading coefficient is 1. And that's factorable. I picked factorable example. And also, as I said, not every single quadratic function is factorable. So we're going to learn them, how to deal with them after, next classes. Okay. The first thing we do, so let's just find out those coefficients, a and b and c. So let me write out the standard form one more time. X squared plus cx plus c. And if you make one-on-one match to this example, so this is your a, that's your b, and that's your c. So we make a list of those because we're going to need those underneath when we calculate, other components. A, b, and c should be clearly known, so you write them down first. So a is 1, b is negative 6, and c is 8. Then at this point, just because a is positive, 1 is positive, we know that graph is going to opens up like that. Or they just provided this way too. Our parabola is going to open up. Go down the second stage. We're going to find axis of symmetry. That's an important one. That's a vertical line that cuts graph into two equal parts. Two equal parts. It's called axis of symmetry or line of symmetry. And we use the formula to find that. It depends on the coefficients, a and b and c. So in this case, specifically b and a. So the formula says, I'm going to write one more time. X equals, vertical line always starts by x. So horizontal line, y equals, starts by y equals 1. So minus b over 2a. And just, substitute those values and find out what that value is. And again, that's our formula, and we plug those, substitute b and a as it is, and do the mathematics. That ends up to 3, and that equals 3 over there. So our line of symmetry is just x equals 3. Okay, I see a question in the chat box. Carlos says, why do we need another negative sign for 6? Oh, okay, that's a good question. So the issue is that when you write a formula right over here, I'm going to write one more time, minus division line b over 2a. That negative sign comes from the formula. You have to use that. And b itself might be negative as well. So that's why they put this negative sign one more time into the parentheses. So distinguish one from another one. This comes from the formula again that b must be itself a negative or positive. So again, that one right over here, that comes from the formula, and this one b itself is negative. So when you distribute negative times negative 6, that's why we have positive 6 on the top, 2 on the bottom, and ends up by 3. 6 divided by 2. Thanks, Carlos. That's a good question. And then just going down, we figured out, a line of symmetry, x equals 3. Actually, that, let me indicate that. Clean this out quickly. So, when you have a graph like this, just the illustration, the line of symmetry cuts the graph into 2 equal parts like that. 2 equal parts. That means has to cross the vertex. That's the vertex point. So always that distance must be equal to that one to get the symmetry. So once you figure out the line of the symmetry, actually you figure out x coordinate of the vertex as well. That's the good part. So the only thing we have to do that we need to find the y coordinate of the vertex, which is our next step. Okay, so this is your vertex. From the top, we figured out that x coordinate is 3. Then we're gonna find out y component. That's easy. If the vertex is on the graph and x coordinate is 3, all we have to do, we're gonna substitute x by 3 and find out what the y coordinate is. So this is the function. Replace every x by 3. Do the mathematics. We end up by -1. That's our. Oops, let's clean up this. -1. That's our vertex coordinate. So our function opens up, and our vertex right over here, minimum point, coordinate 3 and -1. So finish the step 3. Now, as we mentioned earlier, we need y-intercept as well, y and x-intercept. So we need to know the point at which graph crosses y-axis. That's the easiest one in the process because over the y-axis, x coordinate is always 0. Doesn't matter what kind of function is this. Simply you go to function and replace x by 0. So mathematically that means f of 0 in the function. So you're going to replace every single x by 0. This one, that one. And when you do the mathematics, you end up by 8. Practical way to say, if you have a function like this, standard form, x squared plus bx plus c. C is always y-intercept, a term without x. Because when you replace other x's by 0, 0, 0, what's left? Only c. In this case, 8 is on the c right over there. Instead of c, in standard form, we had 8. That's our y-intercept. So our graph's going to cross y-intercept at that point. Okay? So finally, we need to figure out x-intercepts. That's the important part. So that means, with the same logic of a y-intercept, over the x-intercept, y coordinate is always 0. So therefore, if we can equalize this, this was our function, x squared minus 6x plus 8. Now, equalize y to the 0. Because over the x-intercept, y is always 0. That turns into a quadratic equation that we need to solve. That's why we practiced this yesterday. We learned how to solve those equations by factoring. And we're going to use today. So, simply we factor in the first and last term. We just well practiced yesterday, those two. And break into 2 pieces, 2 factors, just like that. X minus 2 times x minus 4. So simply remember that. How would you factor that? That would be x and x. 8 would be 2 and 4, but you need -6 in the middle, both negative. And solve those equations, find out 2 of those. In this case, we have 2 x-intercepts, 2 and 4. And point-wise, coordinate-wise, 2, 0 and 4, 0. As you can see. So far we got, we know that the graph is going to open up. It's going to open up. And we got the y-intercept. We just got two x-intercepts. We had the vertex coordinates. Now all you have to do right now, put that into an coordinate system and just plot those points and combine it. So let's check our points in the scale graph. Those two are x-intercepts. This is a scale graph, by the way. That is our y-intercept. Okay, that's our line of symmetry. Again, that's important one. X equals 3, vertical line. And also that point, right? See, it's vertex 3 and -1. Some textbooks call them turning point. So that's our graph. Okay, guys. Now in the chat box, we're gonna scale our understanding. Okay, 1 to 3. If you understood process and ready for the practice, so because I'm gonna put you in the breakout sessions, put 1 in chat box. If you got mostly correct, but you need to practice, that's just put 2. And if you're not ready for the practice, just put 3 in the chat box. So for those who are not ready, we're gonna continue the lesson. And those who are ready for practice, I'm gonna put you in a practice session and I'm gonna visit you each of those breakout session rooms. So please, all of you, I need to see 25 responses. Okay. That means we're all ready for breakout sessions. Okay. All right then. So if you log into Canvas, so you're gonna see this file as a PDF. And those are the problems you need to go over by your group of 3. And at the end, if you slide down, end of the page, you want to see the answer sheet right over there, answer key. Do the problem first and check the answer later. So this is for your verification. So, and if you miss something, go back and try to catch your mistake. And when I visit your rooms, so we can clarify those points. You guys. And after the breakout sessions, don't forget, we're going to have one more problem and we're going to finalize the day.